Imagine for a moment that today I give you 1 coin. Then tomorrow, the 1 coin becomes 2. The day after that, the 2 coins becomes 4. And 4 now becomes 8. Then the day after that, the 4 coins become 16 coins. And the 16 become 32. And 32 becomes 64. What exactly do you think is happening? Very quickly, you realize that we are not just adding up or increasing the numbers of coins, but we are actually doubling. So 1 becomes 2, and 2 becomes 4, 4 becomes 8. So exactly what we are actually doing is we are doubling the number of coins. So very quickly, you realize that the number of coins increases so much. So you can even see that for the 16 number coins, I don't even have space to show all of them. So now imagine that you write 2. And then you write 2 times 2. That means the 2 has doubled to become 2 times 2. Then 2 times 2 has doubled to become 2 times 2 times 2 times 2. And then you double this one too. It becomes 2 times 2 8 times. And then you double 2 times 2 8 times to become 2 times 2 16 times. So at each level, you are doubling. So imagine writing that today, write 2. The following day, write 2 times 2. The day after that, write 2 times 2 times 2 times 2. Very quickly, you realize that it becomes so tiring and boring to write the numbers like that. Because if you pick one number and you are asked to keep multiplying the numbers over and over again, you multiply 2, you multiply again and again and again. Who would like to be writing things like this? So mathematicians then ask themselves, how can we describe repeated multiplication in a simple way? How? How can we describe repeated multiplication in a simple way? Because if you see what we are doing, we are just repeating the multiplications. And that is how come they came up with indices. So indices simply refers to repeated multiplication, having a shorthand way of writing repeated multiplication. So that's how come indices was born. So for example, instead of writing 2 times 2 times 2 times 2 or 2 times itself 4 times, mathematicians just decided to write 2 to the power 4. It means 2 is multiplied by itself 4 times. That's basically what it means. 2 multiplied by itself 4 times. The 2 in this example is known as the base number, or the factor that you are using to multiply by itself. Then the number at the top is known as the exponent, or the index, or the power. So the 2 at the top is called exponent or index or power. So we can say 2 exponent 4 or 2 to the power 4 or 2 index 4. And then the plural form of index is indices. So basically that's where the indices comes from. So that is the whole idea about what indices. So now that the foundation has been clearly laid out for us, let's go deep into it. So I have a question for you. That is, so from the little explanation I've given earlier, if I say 2 to the power 3, what does it mean? 2 to the power 3. What does 2 to the power 3 mean? Please interact with me in this video. So if possible, whatever you think 2 to the power 3 means, write it in the comment section. 2 to the power 3, write it in the comment section. Let's see. What did you get, or what did you write? I'll read the comment to see exactly what you've written. So when we talk about indices is more like a shortcut, a shorthand, a shortcut you would use to get to a destination instead of passing the long road. So instead of writing 2 times 2 times 2 times 2 times 2 times 2 8 times, you just write 2 to the power 8. So 2 to the power 8 becomes an index form of that number. It's a short way of writing it. And indices is not just a shortcut or a shorthand of writing things. It helps us to describe how things grow exponentially. For example, how population grows and how maybe viruses spread in a population and how much money grows in the bank. So indices is so powerful and helpful. So basically, it shows us how fast things actually grow. But now let's slow down to analyze something so much. For example, if we have 2 to the power 4, what it basically means, as I've explained earlier, is 2 multiplied by itself 4 times. That is what it means. 2 to the power 4 means 2 multiplied by itself 4 times. But here is the actual question we are most concerned about. Now, what happens if we multiply numbers by themselves, or when we start multiplying indices? So 2 to the power 4, imagine, or what happens when we start combining powers? What exactly happens? And this is what I mean. Imagine we have 2 to the power 4 times 2 to the power 3. You can see that 2 to the power 4, the base is 2 and the exponent is 4. And 2 to the power 3, the base is 2 and the exponent is 3. So what happens if we start combining them using some arithmetics like multiplication and division? What happens? So that's what we'll be discussing. So let's analyze the first one. 2 to the power 4 times 2 to the power 3. Well, do not stress yourself too much. We are going to take them stepwise. So 2 to the power 4, you know, is the same as 2 times 2 times 2 times 2. That is 2 times itself 4 times. You got that, right? Then there is a multiplication sign. So 2 times 2 times 2 times 2 times. Now 2 to the power 3. 2 to the power 3 is the same as 2 times 2 times 2. So 2 to the power 4 times 2 to the power 3, if you pick them one after the other, you'll realize that 2 to the power 4 can be written this way and 2 to the power 3 can be written that way. Now what I want you to do is look at the numbers at the down. You can see that we only have 2 throughout. The only factor there is 2, so let's write it out, 2. Now count the number of times 2 appears on the screen. For the first one, it appears 4 times, and the second one, it appears 3 times. So if you check the number of times 2 appears, in total, it appears 7 times. So you will write it at the top of 2. So you have 2 to the power 7, or 2 exponent 7, or 2 index 7. I think that is clear, right? But here's a question. Where does this 7 actually come from? You see that it actually comes from the addition of the number of times the factor appears, right? But what if I tell you there's an easy way of doing it? You see, when you have 2 to the power 4 times 2 to the power 3, and we have to expand them and then find the number of times they appear, there's actually an easy way of doing it. Here's the easy way. Look at the numbers on top of the 2 to the power 4. There is 4 and there is 3, right? So imagine we add the 4 and the 3. So 4 plus 3 gives us 7. Can you see that this 7 is the same as the 7 on top of the 2? I hope you see that, right? So now that we've seen the connection between the powers and the answers that we've gotten, that leads us directly to the first law of indices. So how would we understand the first law of indices? Suppose we have this expression, a exponent m times a exponent n. The a is the number, also known as the base. So you can see that the a is the same as the a exponent m has the same base as a exponent n. So according to the first law of indices, if you have numbers of the same base, just pick one of the bases, which is in this case is a, then you drop the exponents and then add them together. That's basically what the first law of indices is all about. So according to this first law of indices, when multiplying indices with the same base, add the powers. When multiplying indices with the same base, add the powers. So let's pick an example. We have 2 to the power 4 times 2 raised to the power 2 times 2 raised to the power 3. What does that mean? Since they all have the same base, 2, 2, 2, we will just write one of that. And then pick all the powers, add them. So we pick the base, which is the 2. Then what are the powers? The powers, we have 2, we have 4, we have 2, we have 3. So 4 plus 2 plus 3. So the final answer will be 2 to the power 9. Because 4 plus 2 is 6, 6 plus 3 is 9. So this is what the first law of indices is referring to. Now look at the definition. When multiplying indices with the same base, that's the first law, add the powers. So one thing you should always check is the bases should be the same. So for example, imagine we have 2 to the power 4 times 2 to the power times 3 to the power 2. 2 to the power 4 times 3 raised to the power 2. Do they have the same base? The answer obviously is no, because the first number, the base is 2, and the second number, the base is 3. So obviously, 2 to the power 4 times 3 to the power 2 cannot be operated on using the first law of indices because their bases are different. Their bases are different. So now that we understand the first law of indices, let's move on to the second law of indices. But before we look at exactly what the law states, look at this. We have 2 to the power 5 divided by 2 to the power 3. 2 to the power 5 divided by 2 to the power 3. Look at one interesting thing. Let's look at the number at the top, the numerator 2 to the power 5. Are you aware that 2 to the power 5 is the same as 2 times 2 times 2 times 2 times 2? That is 2 multiplied by itself 5 times. Are you aware of that? Hopefully you are. And then divided, this number at the top is divided by 2 to the power 3. 2 to the power 3, what does that mean? What does it mean? Write in the comment section. Let's interact with each other in the comment section. Write it. What did you write? Pause the video and write what you think 2 to the power 3 means. Okay, actually it means 2 multiplied by itself 3 times. So now we have 2 multiplied by itself 5 times and 2 multiplied by itself 3 times. They are dividing. So what happens? Since the numbers or the factors are the same, the number, which is the 2 at the top, the first one cancels the first number at the down. The second one also handles the second one. And the third one from the top will handle the third one from the down. So they've actually taken care of each other. And what do we have left? We have 2 times 2 left. 2 times 2 left. And 2 times 2, remember the first law that we discussed? You see, the first 2 is actually 2 exponent 1, but it's not written. And the second 2 is also 2 exponent 1. So 2 exponent 1 times 2 exponent 1, you just write the 2, they add the exponent 1 plus 1 is what? Is 2. Yeah, that's one interesting thing about indices. When you have exponents of 1, we do not write them. If it is positive 1, unless otherwise it's negative 1. If it is 2 exponent negative 1, that's when you have to write the negative 1. But if it is exponent positive 1, we don't show it. So 2 is the same as 2 to the power 1. So we add the exponents, now you have 2 to the power 2. I think that is clear enough. Now I have a question for you. That 2 on top, where does it come from? The 2 to the power 2. And I think you understand where it comes from, but I want you to open your eyes to something. Look at the original fraction I gave you, 2 to the power 5 divided by 2 to the power 3. Look at their powers. The powers are 5 and 3. Got it, right? Powers are 5 and 3. Suppose we pick the first number, 5, and subtract the second number from the 3. What do we get? We get 2. So 5 minus 3 is 2. Do you see that? 5 minus 3 is 2. Good. Remember, it is the top number minus the down number. The top number is 5 minus the lower exponent is 3. You see that this 2 is the same as the 2 on top of the 2 exponent 2. Do you get that? So you see the connection between how we expanded and solved it and a short way of finding it. So that leads us smoothly to the second law of indices. So what that law means, or how we apply it, is this. If you have two numbers that have the same base, for this one it is a to the power m divided by a to the power n. Their bases are the same. The bases are a. And the exponents are different. So what you're going to do is to pick the base, one of them, which is the a, and then bring the exponents together. The first exponent, which is m, minus the second exponent, which is n. I hope that's clear, right? The first exponent minus the second exponent. So basically, that is how the division law of indices works. So what does the law state? It says that when dividing indices with the same base, subtract the powers. When dividing indices with the same base, subtract the powers. So we'll pick an example. So you have 2 to the power 8 divided by 2 to the power 2 divided by 2 to the power 3. So first off, they have the same base. 2, 2, 2 is the powers that are different. So what we have to do is to just pick the base, which is 2. And what do? We subtract the powers. The first power is 8 minus the second power, which is 2, minus the third power, which is 3. So 2 to the power 8 minus 2 to the power 8 minus 2 minus 3. And what would that give us? It gives us 2 to the power 3. Because 8 minus 2 is what? 2 to the power 3? Yeah, 8 minus 2 is 6. And 6 minus 3 is 3. Yeah, I think I nearly got confused out there. Good. I think the whole thing makes sense now. Now I have a question for you. Suppose we have 2 to the power 4 divided by 3 to the power 2. What is the answer? Can you actually use the second law of indices on this? I want you to write it in the comment section. Let's talk in the comment section. Let's talk. So 2 to the power 4 divided by 3 to the power 2. Can we use the second law of indices on it? If we can, explain it in the comment section. If it is not possible, write why it is not possible in the comment section. Let's interact with each other. So I think the first law is cleared out, the second law is cleared out. It's just one example each. Now let's look at the third law of indices, which will be the final one in this lesson. But before we look at the third law of indices, look at this question. 2 to the power 3 in brackets, exponent or index or raised to the power 2. Can we solve this? Yes. But before we look at the third law of indices and how to apply it on this, I want you to look at this. Let's pick the number in the bracket, which is 2 to the power 3. 2 to the power 3 is in the bracket. Let's pick it. What does 2 to the power 3 means? It means 2 times 2 times 2, or 2 multiplied by itself 3 times. I hope that's clear. So that means what is in the bracket is actually 2 times 2 times 2. So that means 2 to the power 3, bracket opens, or bracket to the power 2 is the same as, we are going to replace what's in the bracket, which is 2 to the power 3. We are going to replace it with 2 times 2 times 2. You get it, right? So what is in the bracket, which is 2 to the power 3, we'll replace it with 2 times 2 times 2. So what is on the right side is the same as what is on the left. Now my question to you is, the 2 on top of what is in the bracket, what does that mean? What does this mean? 2 on top. Do you know what it means? Can you say it in the comment section? Yeah, write it. Right, pause the video and write it in the comment section. Anyone who writes it and I read, that means the person actually paused the video and wrote it. Okay, now that you are done writing it, this is what it means. The 2 on top simply means that double it, double what is in the bracket, or multiply what is in the bracket by itself. Remember, 2 to the power 2 means multiply 2 by itself 2 times 2. So what is in the bracket multiplied by itself? That is what the 2 on top means. So 2 times 2 times 2 times 2 times 2 times 2. That's what it means. Good, I think we are making progress. Now, by applying the simple idea we got from the first law of indices, you see we have the same base 2 times 2 times 2 times 2 times 2, 6 times. So the common factor here is 2. How many times does it appear? It appears 6 times. I think that's clear, right? So now my question is, where does this 6 comes from? You say, okay, yeah, we did it just now when it comes from just counting the number of times 2 appears. That's true. But if I tell this a short way of doing, an easier way of doing it. Now look at the question again, 2 to the power 3, brackets, or into bracket to the power 2. Now look at the numbers on top, 2 and 3. Suppose we multiply them. 2 times 3. It gives us what? 6. And can you see that 6 is the same as the 6 on top of the 2? Yes. So that lays the groundwork for the third law. What does the third law of indices state? Well, let's look at it with this. We have a number which is a to the power m, or into brackets, to the power n. What do you do? Well, from what we've discussed already, just pick the base and then pick the 2 powers and multiply them. So m times n. So this basically, according to the third law, basically they said when an index is raised to another power, multiply the powers. When an index is raised to another power, for example, the other power is n, so you multiply the powers. So let's look at an example like the one we discussed earlier. 2 to the power 3 into brackets to the power 2. Just write the base, which is 2, and multiply the powers, and the powers are 3 and 2. So 2 exponent 3 times 2, and it is the same as 2 to the power 6. So that's what the third law of indices states. I think the first, second, and third law are cleared out. We've only looked at the laws and one example each. In our next lesson, we'll be looking at some special laws of indices, which are the negatives and zeros of indices. We'll be looking at that. And after that, we'll be picking questions to actually revise the first 3 laws and those laws that I'll be discussing. So this brings us to the end of this particular lesson on indices. See you in our next lesson on zeros and negatives of indices. So this brings us to the end of our lesson on indices, and more specifically the first 3 laws of indices. So if you have not subscribed to the channel yet, subscribe to it now and put out a post notification so that you wouldn't miss our next lesson. But a quick shout out to some students that actually completed our lesson on trigonometric ratios. We have Roy King, Miriam, Vanessa Luchu, we have Geoffrey Osafo Osai. We have someone called Icon or Icon. Yeah, I think Icon. Yeah. Then we have Sedem, Benjamin Ofori. Then we have Kelvin, and then Hans. Yes, if I pronounce these names well. So these were the students that completed our previous lesson on. The assignments are attached to our previous lesson on trigonometry. So that's that. See you in our next lesson.